Very good evening to all. Audio video clear? Audio video clear? Yes, audio video is clear. Please let me know audio video is clear or not. Okay. In last class we started grammar. So according to the Chomsky, grammar classified into three categories: type 3, type 2, type 1, and another is type 0. Type 0. So first we will see type 0. Type 0. Type 0. So type 0 is also known as unrestricted grammar. Type 0 is also known as unrestricted grammar. It means there is no restriction. There is no restriction. There is no restriction. It is also known as universal grammar. Also known as universal grammar. Grammar. So what is the mathematical definition of this one? Left hand side determine right hand side. Left hand side determines something in right hand side. So there is in left hand side at least one non-terminal. At least one non-terminal. At least one non-terminal. And right hand side anything. Terminal, non-terminal, anything. And right hand side anything. So this is the definition of unrestricted grammar or type 0 grammar. Type 0 grammar. Type 0 grammar. Clear? Next is type 1 grammar. Type 1. Type 1 is also known as context sensitive grammar. Context sensitive grammar. Length increasing grammar. Length increasing grammar, or it is also known as non-contract grammar. Non-contract grammar. Non-contract. So there is some restriction as compared to the type 0. So what are the restrictions? Please see here. First, it must be a type 0. It must be a type 0. What is the definition? Alpha determines beta. Alpha determines beta. And another restriction is mod of alpha less than equal to mod of beta. Means the length of the left hand side should be less than equal to length of the right hand side. What is alpha? Alpha belongs to any number of terminal including epsilon, at least one variable. Sorry, at least one variable. And beta belongs to any number of variable and terminal excluding epsilon. Excluding epsilon. Clear? There is some exception. To satisfy the norm Chomsky hierarchy, if epsilon is present in the grammar, if epsilon is present in the language, then it is determined only by the starting symbol and s not appear anywhere in the right hand side. Please listen carefully. Please listen carefully. Because in beta we don't consider epsilon. If epsilon is come into the grammar, if epsilon come into the language to satisfy the norm Chomsky hierarchy, we put epsilon with the starting symbol, and starting symbol does not appear anywhere in the right hand side. So this is the definition of type 1 grammar. Type 1 grammar. Left hand side any combination of variable and terminal, right hand side any combination of variable and terminal, and length of the left hand side should be less than equal to length of the right hand side. So this is the definition of type 1 grammar. Next is type 2. Type 2. So what is type 2? Type 2 is known as context free grammar. Context free. So what is the definition? A determines alpha exactly one variable. Exactly one variable. In right hand side, alpha belongs to any number of variable and terminal including epsilon. Including epsilon. So it must be type 0, type 1. Type 1. So this is the definition of type 2 grammar. Clear? Next, type 1 grammar. Sorry, type 3. Type 3. Type 3 is known as regular grammar. Regular grammar. So first point, it must be type 0, 1, 2. Second, what is the definition? A determines ABA or A determines BAA, where A and B belongs to variable and A belongs to terminal. A belongs to terminal. A belongs to terminal. Terminal. A belongs to terminal. A belongs to terminal. Any combination of terminals. So my dear friends, please listen carefully. This is known as right linear grammar. And this one is known as left linear grammar. So when a it means for regular grammar we have a linear grammar. Then all regular grammars are linear. Yes, all regular grammars are linear, but all linear grammars are not regular. Another important point is note. In regular grammar, all production either right linear or left linear. Either all production are right linear or left linear. The power of right linear and left linear are same. The power of right linear and left linear are same. So now, what is a linear grammar? Linear grammar. What is linear grammar? At most one non-terminal at the right hand side. At most one non-terminal at the right hand side. Another important point, all regular grammar are linear, but reverse is not true. Not true. Clear? So please note this point. Please note this point. Okay. So, see, what is regular language? Regular language. What is regular language? What is regular language? Language for which we can construct at least one regular grammar. Language for which we can construct at least one regular grammar. So another important point is here, for one language we can construct many grammars. For one language we can construct many grammar. So our next topic is construction of grammar. Construction of grammar for the given language. For the given language. For the given language. So first we will talk about the regular languages. First we will talk about the regular languages. So listen carefully, my dear friends. For construction purpose, grammar, we use restricted right linear grammar. Sir, what is the restricted right linear grammar? Here we perform some restriction on right linear grammar. Sir, why we use this one? Why we not use right linear grammar? My dear friends, when we use a restricted right linear grammar, then in next lecture you will see the construction of finite automata from the grammar is very easy. So for construction, for easy sake of easiness, we use restricted right linear grammar for construction. So what is the restricted right linear grammar? See, my dear friends, A determines A exactly one terminal. A, B or epsilon. This is the definition of restricted right linear grammar, where A comma belongs to variable and A belongs to exactly one terminal. Exactly one terminal. Clear? Clear, my dear friends? Okay. Now, start the construction of grammar. Question 1. Construct regular grammar which generate all strings of A's and B's, construct regular grammar which generate all strings of A's and B's, including epsilon. So, my dear friends, first you write the language. Then try to construct the restricted right linear grammar. So, see, what is the language? L contain epsilon, single A, single B, double A, AB, BA, BB, and many more strings. So, this is the starting symbol of the grammar. It generate epsilon, single A, S, BS. So see, this is the restricted right linear grammar. And it generate all the strings which are present in this language. Suppose we want to generate epsilon. So S directly generate epsilon. If I want to generate single A, then take this production AS, put epsilon instead of A, so it generate A. If I generate B, then S determines BS, put epsilon instead of S, then it generate B. Now check how it generate double A. S determines AS, again S determine AS, put epsilon instead of S. So it generate all the strings which are present in the language. Is it clear, my dear friends? Please reply me fast. Is this clear or not? And see, this is the restricted form. Right linear form. I am waiting your response. Is it clear? Is this grammar is clear or not? Please reply me fast. Yes. Okay. Next question. Next question. Construct a regular grammar which generate all string of A's and B's where each string start with A. Construct a regular grammar which generate all strings of A's and B's where each string start with A. So first you construct the language, this one, then try to construct grammar in the restricted right linear form. So see, what is the language? Start with A. It means single A is present, AA is present, AB is present, and many more. So S is the our start symbol. So it generate A and another variable capital A. Now this A generates AA, BA or epsilon. So see, this is the grammar that generate this language, and it is in the form of restricted right linear. Restricted right linear. Clear? Clear? Restricted right linear. Now, next question, where each string start with double A. Start with double A. Start with double A. So, my dear friends, what is the language? What is the language? And what are the strings that present in this language? Double A, double AB, triple A, double AB, and many more. So S determines A, capital A. Capital A determines one more A because we want at least 2A. So another variable B. B determines any number of A's, any number of B's or epsilon. So this is the restricted right linear grammar corresponding the given language. So how to generate double A? S determine AA, A determines AB, and put epsilon instead of B. So it generate double A. How it generate triple A? S determine AA, again A determine AA, A determine AB. Sorry, this one is B. Wait, instead of this A we have a AB, instead of B we have this production, put epsilon instead of B. So this generate triple B. Clear? 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 So now, next question. End with AA, end with AA, end with AA. Sheikh Saab, which one is not valid? See, which one is not valid, my dear friend? I'm not right here AAA. I'm not right here like that. Sheikh Saab, am I right? Yes or no? Yes? Sheikh, give me a fast reply. I'm not right here. The AA capital A. Clear? So, next question. End with double A. Double A, why it is not valid? Because it does not satisfy the restricted right linear form. So what is the restricted right linear form? Please listen carefully. This is the restricted right linear form. A, B, A, epsilon. This is the restricted right linear form. So this production is not satisfy the restricted right linear form. If I take for construction restricted right linear form, then this is not valid. Otherwise it is valid. Otherwise it is valid. It is a regular production. It is a regular production. Is it clear? Is it clear, my dear friend? Now end with where each string end with double A. So what are the strings present in the language? Double A, triple A, B double A, and many more. So this is our start symbol. It generates A, S, B, S, and terminate S with double A. This is also valid, but it is not follow the right restricted right linear. It is valid regular grammar. It is valid regular grammar, but this grammar does not follow the rule of restricted right linear form because of this. So what is the restricted right linear form? A, S, B, S, A, capital A. Capital A generate A, epsilon. A, epsilon. Clear? Or sorry, it because of this it generate only single A. So this is not. Terminate A with a small a. So this grammar generate this language and it follow the restricted right linear form. Why we use sir, you are take lecture. एक्चुअल में हिंदी वाले चैनल पे सुबह स्टूडेंट्स नहीं आ पा रहे थे, इसलिए मैं यहाँ ले रहा हूँ. ठीक है, तो इट्स माय हम्बल रिक्वेस्ट टू ऑल ऑफ यू, प्लीज कम टू दिस चैनल. वी विल कंप्लीट TOC हियर. सुबह अर्ली मॉर्निंग मैं थोड़ा सा बिजी भी हो जा रहा था. एक्चुअली मुझे जाना होता है ऑफिस, तो मैं बिजी हो जा रहा था, इसलिए दैट्स व्हाई आई एम नॉट टेकिंग lectures in the morning. We will complete TOC here, so it's my humble request to all the students, please come here and we will complete TOC. Okay, Sheikh? से आप लोग प्लीज इसी टाइमिंग पे आ जाइए ना, प्लीज आप लोग इसी टाइमिंग पे आ जाइए. इट्स माई हम्बल रिक्वेस्ट टू यू. नाउ नेक्स्ट क्वेश्चन. Start with A, end with A. Construct a regular grammar which generate all string of A's and B's where each string start with A and end with B. Where each string start with A and end with A, where each string start with A and end with A. So Sheikh, it's my humble request, प्लीज आप लोग इसी बैच में आ जाइए. आप लोग सारे लोग इसी बैच में आइए. डेफिनेटली आई विल कंप्लीट होल TOC विथ ऑल प्रीवियस ईयर क्वेश्चंस. ओके, सो इन्फॉर्म अदर्स. Start with A and end with A. So what is the language? Contain strings small a, single a, double a, ABA, triple A, and so on. So S generate single A, yes. S generate single A. It generate AA, and how to terminate this A? A determines हिंदी है भाई, आधा हिंदी में आधा इंग्लिश में. ठीक है, आधा हिंदी में पढ़ेंगे आधा इंग्लिश में पढ़ेंगे. ओके, ठीक है ना शेख? आधा हिंदी में पढ़ेंगे आधा इंग्लिश में पढ़ेंगे. क्लियर? सो A determines small a slash small a capital A. How to terminate A? A, it generate any number of A's, it generate any number of B's. Whenever we terminate A with small a, okay? जब भी हम A को terminate करेंगे तो small a से terminate करेंगे. Are you getting my point? सेक इन्फॉर्म अदर्स. ठीक है, हिंदी और इंग्लिश दोनों का कॉम्बिनेशन में पढ़ेंगे हम. ठीक है, इन्फॉर्म अदर्स. whenever we terminate A, so it always terminate by this A. So we can generate any string from this language. If I generate this one, so see AA, put this production ABA and put small a instead of capital A. So it generate ABA, starting with A, ending with A, starting with A, ending with A. Clear? Clear? और आप लोग आ जाओगे तो मैं इसका टाइम भी बढ़ा दूंगा, थोड़ा सा टाइम और बढ़ा दूंगा और मजा भी आएगा पढ़ने में. ठीक है? क्लियर हो गया? मैं टाइम भी इसका इंक्रीज करूंगा. आई विल इंक्रीज द टाइम फॉर दिस क्लास. नेक्स्ट क्वेश्चन. वेयर ईच स्ट्रिंग स्टार्ट विथ ए एंड एंड विथ बी. सो व्हाट आर द स्ट्रिंग्स प्रेजेंट इन दिस लैंग्वेज? At least AB is present. A, B is present, A, B is present, and many more. So see, S generate A, start with A and end with B. Start with A and with B. So only this production. A generate any number of A's, B's, and whenever we terminate A, it always terminate by B. It always terminate by B. Clear? So this grammar is clear to you? Next, where each string start and end with same symbol. Start and end with different symbol. Start and end with different symbol. हमें एक ऐसी ग्रामर बनानी है, रेगुलर ग्रामर बनानी है जो ऐसी स्ट्रिंग्स जनरेट करे जिनका स्टार्टिंग एंड एंडिंग सिंबल्स डिफरेंट होना चाहिए. तो व्हाट आर द स्ट्रिंग्स कंटेन इन दिस लैंग्वेज? ए बी, बी ए एंड मेनी मोर. सो एस start with A, start with B. Okay, start with A, start with B. This A generate any number of A's, any number of B's, and whenever we terminate this A, it is always terminated by small b. It is always terminated by small b. Clear? Now, what about this when string start with B? After B, we can have any number of A's, any number of B's, and whenever B is terminate, it always terminate by A. It always terminate by A. So this is the language which generate each language where each string start and end with different symbol. Start and end with different symbol. Clear? Now, if I use here same symbol instead of different, same. So, what are the strings present in this language? Epsilon, single A, single B, AA, BB, and many more. So, see my dear friends, S determine either it start with A or it start with B. It generates single A, single B, or epsilon. What about A? A determines any number of A's, any number of B's, and whenever A is terminated, it terminated by small b. Sorry, because we want to same start and end with same symbol, so it terminated by small a. What about capital B? It always terminates by B. So this is the grammar that generate all the strings where starting and ending with same symbols. Clear है भैया? Clear है सबको? Clear है? जल्दी से बताएं. Is it clear to all of you? Is it clear to all of you? Shall we move on next question? Yes? Okay. Next question. AA as a substring. where each string contain AA as a substring. A as a substring. So language contain at least double A and many more strings. So S determine A. Now it start with A or it also start with B. Yes or no? Yes or no? Or we can write like that. S determine AS BS. And if I want to terminate as, then we use AA. And A generate AA. A. See, all the string is or we can A double A. If I generate no, this is there is we use another terminal B and B generate A B B and it is terminated by epsilon. Now it is perfect. It is perfect. So sir, why we use this production? My dear friend, see, if I take this one, S determine AS, this string is also present in this language. So either it is start with A or it is start with B. So if I generate double A, then we take this production. Okay. Instead of A, we replace AB. Instead of B, we put epsilon. So it generate double A. Now check B, how to generate B double A. Take this production. S determine BS. Put AA instead of this and put AB and put epsilon instead of B. Clear? Clear? Say clear? Is it clear? Now, next question. If BB is a substring, then what will happen? If BB is a substring, then language contain at least double B and many more strings. So string start with A or start with B and it generate double B. So we use here another production BA. So A determines B, another production B. B determines any number of A's, any number of B's or epsilon. Clear? 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 Now, next question. Contain single A as a substring, A as a substring, A as a substring. Then what is the language and what is the grammar? L contain at least single A. It contain BA. It contain AA and many more. So S generate either it start with A or start with B, or it generates single A. So A, B, A, epsilon. So this is the grammar that generate A as a substring. A as a substring. A as a substring. Or my dear friends, we can remove this production also. We can remove this production also. There is no need of this production. There is no need of this production. Because from here it start with A. From here it start with A. From here it start with B. It start with B. Clear? Clear? Now, next question. Construct a regular grammar which generate all string of A's and B's where each string contain number of A's divisible by 3. Number of A's divisible by 3. By 3. So this grammar, this language contains strings epsilon, single B, double B, triple B, any number of B's. Triple A, B, A, B, A, B, A, and many more strings. Clear? Clear? So how to generate, how to construct grammar for this ones? S generate epsilon. S generate any number of B's. S generate any number of B's. Clear? Now come to the A. A. Because we want to set we want to follow the restricted linear grammar, right linear grammar. So A generate A, another variable B. So now we have till here we generate two A's. S determine AA, instead of A we replace with B. Now we have generate another A, or A determines AB. A determines AB. If I generate B between A, then we use BA. BA. Now, what about this one? B determine A. Or 1A, 2A, 3A. Now come to S, and it generate any number of B's. Any number of B's. Any number of B's. So see, this is the regular grammar that generate number of A's divisible by 3. Number of A's divisible by 3. Number of A's divisible by 3. Please check once. Please check once. Please check once, my dear friends. Clear? Now, another question. Number of A is divisible by 1 mod 3. Means When we divide number of A's by 3, remainder always 1. Always 1. So what are the strings that are present in the language? Single A is present, AB is present, BA is present, or minimum length strings BBA, any number of B's, BAB, this type of strings are present. So A, A, A. What about B? What about B? What about B? B in between any number of B's. Now, A generate. A generate. What A will generate? First of it generate epsilon. Why? If I put epsilon here, then it generates single A. Now, next one. A, B, B, A. Why? Why this one? Why this one? Now, what B generate? 1A, 2A, 3A, 3A, and any number of B's epsilon, epsilon. This grammar generate number of A's 1 mod 3, number of A's 1 mod 3. Clear? Clear? Next one is number of A's 2 mod 3. Please, my dear friends, if you have any query, then please ask me. If you have any query, then please ask me. Two mod 3. 2 mod 3. So what about the 2 mod 3? S generate AA, BS, A generate. See, this one is correct or not? Yes, this one is correct. Just wait. Epsilon is present here or not? S determines A. No, epsilon is not present here. 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 Because of this one, this generate. How to generate 2 A's? See, A. Instead of A, if I put epsilon, then it generates single A. It never generate. If I take epsilon here, then it generate 2 A's. How it generate 2 A's? See, put this production instead of this one and put epsilon for this one. So, epsilon is not present here. Clear? Epsilon is not present here. Now, 2 mod 3. 2 mod 3. Double A is generated, so A, B, BA, BAS, BB, or epsilon. So it generate 2 mod 3. 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 Clear? So if I ask this question, construct a regular grammar which generate all string of A's and B's where each string contain number of A's not divisible by 3. Not divisible by 3. Not divisible by 3. So in case of not divisible by 3, remainder is 1 or 2. When we divide number of A's by 3, then remainder should be 1 or 2. So combine these two. Combine these two. So not divisible by 3. What is the grammar? S determine AS, BS. Epsilon A, B, BA. B determine AS, B, B, epsilon. So this grammar generate number of A's not divisible by 3. Check, it generate single A, double A, 4A, 5A, 7A. So this grammar generate number of A's not divisible by 3. Not divisible by 3. Clear? 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 How this language, please check how this grammar generate this one, BBA. So first you take this production, S determine BS. Instead of this BS, again you will take BS. Instead of this S, you will take this AB. And instead of B, you can put epsilon. So this generate this grammar string. Clear? Clear? Clear, my dear friends? So, no. Today class is over. Next questions we will continue in next class. If you have any query, you can ask me. Sheikh, कोई query है? कोई doubt है? पूछ लो बेटा. If you have any query, any doubt, then ask me. अगर आप सारे लोग यहाँ आ जाएंगे जो हिंदी वाले चैनल पे थे, तो मैं इसका टाइम थोड़ा सा और इंक्रीज कर दूंगा. जितने ज्यादा लोग आ जाएंगे मैं टाइम थोड़ा सा इंक्रीज कर दूंगा. सीख चले, नो डाउट. ओके, we'll continue this portion in next class. Okay, it will take 4 to 5 classes. Grammar part grammar takes 4 to 5 classes. Okay, so thank you so much. Shubh Ratri, Jai Mahakal, Jai Hind, Jai Ma Bharati.